So in the second lecture of duality, we will be starting with greater than types. So here, what is going to happen? So minimization of z 4x1 plus 6x2 plus 18x3, and the subject to functions are x1 plus 3x2 greater than equal to 3, x2 plus 2x3 greater than equal to 5. See, here the first one is missing x3 and the second one is missing 1. So this one is very interesting. So we will be assuming the coefficients as 0. So let's start it. So here the maximization will be, so how many equations here? 2 equations. So on the basis of that, there will be only 2, that is 3w1 z dash equal to, or z star equal to 3w1 plus 5w2, and with respect to that other part is, see, this is 1 3 0 and 0 1 2, that's the matrix. So if we take the transpose, it will become 1 0 3 1 0 2. So here it will be w1 3w1 plus w2 and only w2, and all the things will be less than, as it is a maximization, and that will be these 3 coefficients, that is 4, that is next part is 6, and the last part is 1 8. That's it. Now what happens if it is a mixture of type 5, mixture of greater than, less than, and equal to? So this one will be a little bit more interesting. So z equal to x1 minus 3x2 minus 2x3 subject to 3x1 minus x2 plus 2x3 less than equal to 7, 2x1 minus 4x2 greater than equal to 12. And the third is 4x1 minus 4x1 plus 3x2 and 8x3 equal to, now this one is equal to, so 10. So the mixture of 3 different kind of thing, and they've also given that x1 and x2 are greater than equal to 0, but s3 is unrestricted in sign. There's a very proper way of solving this, because otherwise it will be very hard to get a proper answer. So let's start it. So here, as x3 is unrestricted, so in the answer segment, let me use another color here. So let x3 equal to x3 dash minus x3 double dash. Every time you need to write it. Although if you are given in an MCQ examination, it will not be needed. Okay. Well, x3 dash and x3 double dash, obviously both are positive. So we are writing the main format as minimization of z x1 minus 3x2 minus 2 into x3 dash minus x3 double dash. So we are going to proceed, and all the thing, as it is a minimization, so we need everything in the greater than format. So this needs to be greater than, this is okay, and this needs to be greater. Okay, so let's proceed. So this one needs to be changed, rest of the things are okay. So this one is correct, this one is okay. So please write the equation in your copy, it will be easier for you to cross check. So minus 3x1 plus x2 minus 2x3 greater than equal to minus 7. I'm multiplying minus both sides. Or now our job is to add the unrestricted sign. So minus 2x3 dash plus 2x3 double dash opening the bracket, so let it be 1. Similarly, the second equation will not be changed, but there is no x3, so we will be writing as in this way. That will be 12. Third equation will be again, okay, minus 4x1 plus 3x2 plus 8x3 dash minus 8x3 double dash, and that is equal to greater than 10. And fourth one is 4x1 minus 3x2. Now we are making it minus again. If you see the equation, the first one is okay, and the second one with respect to the sign changes, minus 8x3 dash and plus 8x3 double dash, and that is greater than equal to minus 10. So this is the formation we have. Hence the equivalent dual will be max Z star minus 7W1 plus 12W2 plus 10W3 dash minus 10W3 double dash. So we can rewrite again, incorporating this, we can take 10 common, so this will be minus 7W1, 12W2 and 10W3. And in the subject to segment, again every time we need to write it in W3 minus W3 double dash, and afterwards at the end we can get it as 2W2 minus 4W3 less than equal to 1. Then W1 minus 4W2 minus 3W3 less than equal to minus 3. Minus 2W1 plus 8W3 less than equal to minus 2. And 2W1 minus 8W3 less than equal to 2. So this is the complete formation of the duality, where this is the main optimization function and these are the things, and where you mentioned that W3 is unrestricted in sign. That's it for this type of formation. Now any kind of unrestricted sign is provided to you, you can do it like this. Now coming to the economic interpretations of this duality. Economic interpretation. So the first most important concept is shadow prices. So shadow price is a very important application. Let there be an LPP indicating a production plan. A production plan for the maximization of profit with limitation on the availability of resources. So maximization of profit with limitation on the availability of resources. So in this kind of cases, then the dual we are interested to offload some of the available resources so as to minimize the expected cost. So here the dual will give minimum expected cost, and that's it. That is very important. The minimum expected cost is the target. So if our target is to produce something which will minimize the cost and maximize the profit, not by changing the price, so this is also in the price is actually playing a good role and very important role in the shadow, because the consumers are not seeing it. So simply this type of pricing structure with the help of duality is called shadow pricing. So let me give you an example of shadow pricing now. A firm is engaged in producing two products, A and B. Each of the unit and each unit of product A requires 2 kg of raw material and 4 kg of labor hours. And whereas B requires 3 of each. Each week the farm has the availability of 60 kg of raw material. So raw material total availability is 60 kg. And labor hour is 96 hours. So 1 unit of A yields rupees 40. So A yields 40, and this yields relatively less, 35 rupees in the profit. So basically we need to form the LPP here and formulate the LPP and determine how many units of each product should be produced per week to maximize the profit. So the first part is very easy. The second part is considering the problem, so formulated as a primal problem, write its dual and solve the dual using the simplex method and give the economic interpretation of the dual and shadow prices of the raw material. So simply whenever we are solving a dual problem with respect to primal and find its dual, so that gives us a shadow price. So the first part I have done already in my basic videos, so I'm just writing max Z will be over here. So 40 into x1, let x1 and x2 are produced, so 40x1, 35x2, and with respect to availability this has 4 and 3, so 2 and 3, 2x1 plus 3x2, availability is 60 kg. So less than equal to 60, and then 4x1 plus 3x2 less than equal to 96. So simply that is our formation, we can solve it and we can find the values. Okay, now if we form the dual over here, so the dual will be what? So dual will be minimize Z star 60x1 plus 96x2 subject to 2x1, let it be x1 dash plus 4x2 dash greater than equal to 40, and 3x1 dash plus 3x2 dash greater than equal to 35. That's it. So this is your thing, and if we solve the basic primal over here, solving we will get it as in the basic formation. So solving you will get that x1 dash equal to 20, x2 dash equal to 25 by 3 and x1 equal to 10 by 3. If we just put into the main equation, the profit will be 1000. So this one is easy. Now coming to the economic interpretation. The economic interpretation is the optimal solution of the primal indicates that producing 18 and 8 units per week. So now the primal solution, if we solve the primal over here, so that will give you x1 equal to 18 and x2 equal to 8. But the profit is still be 1000. So the primal says the farm can produce the same amount, and where it is 8 and it is 3. So even by producing less, the same amount of profit is achieved. So suppose that the firm is approaches to a party and how to proceed if they ask. So by the economic interpretation of the duality, we can say by taking any other type of production process, which we always try to do. So in taking same level of profit can be maintained but with less production. So this is the beauty of shadow pricing. So the rental rates W1 and W2, which we are calculated later, is called the shadow prices or the imputed prices, which in general is never disclosed by the seller, and the shadow prices represents not the actual market prices but the true accounting values or the imputed values of the respective ingredients. And the objective function of the dual is to maximize or minimize the total accounting value. So this accounting value is going. So in short, we can summarize that the entire process can be done utilizing this, which can lead you to same profit either by reducing the price of inputs like P1 and P2 can be increased, or by just reducing the X1, X2 by the ingredients requirement. So in this way you can solve any of the question. You please see the simplex based structure, that will be easier for us to proceed. Now in our next video we will be talking about linear programming with unrestricted variable.